more time. Oh, you're welcome. It's DevFest at Ahlen. Let's start.
Okay, thank you so much, Anna. Thank you for inviting me, and hope we have a wonderful presentation now. And Joseph, thank you so much for your presentation. I actually met some part of it, and it was quite interesting. And thank you. Okay, so I'm Tajudeen Nurudeen, and I'm a mobile software engineer, right? I specialize in Flutter development. Although I do other things, but mostly I do Flutter development. And today I'll be walking us through a practical guide on how to use Flutter for robust and scalable mobile applications. Right, so we start with a few definitions. Right? What is a robust application? What does it mean for an application to be scalable? Right. So I think yes. So a robust or scalable application, right? I'll say is just one that is easily maintainable, one that you can easily make changes to, ones that when things changes, like when you have more users, for example, when you have more developers, for example, when you have more people depending on the application, for example, you are easily able to transit from lower number of users to higher number of users and stuff like that, right? You essentially are able to maintain the same efficiency that your application has when it is small, right? Now that it is bigger, or now it supports more user base, right? So essentially, what we're trying to, what I'll be working us through is how to ensure that when things become bigger, when our user base, for example, becomes bigger, when the number of developers that are working on a particular solution or on the application becomes larger, the application is still easily maintainable, and we're still able to, have the same efficiency that we had when we probably were working with a few number of developers or a few number of users. So essentially, that's what a scalable application is. So this is just some things about myself. Once again, Tajudeen Nurudeen, I'm a mobile engineer. Uh, I'm studying for an MSc in Artificial Intelligence and Machine Learning, and I have a BTech in Computer Science. And with this session for, essentially, the session is for aspiring developers, right? Those that want to be developers, right? Especially that they intend to be Flutter developers. And also professional engineers, right? Professional developers already, who already build stuffs, right? And they just want to learn one or two things and how to make the application better, how to make it more scalable and more maintainable. And also, it might be for managers who are curious about Flutter, right? You might just want to know one or two things about Flutter. And I think this presentation will also, serve some purpose to help you understand a bit about Flutter for a manager, right? So the agenda includes building scalable applications, best practices and tools that helps you to build scalable applications, and some demos, right, and insights here and there, right? I'll try to keep it as short as possible, and I'll make my explanation as as brief as I can. Right. So what does it mean when an application grows? What does it mean when an application grows? Essentially, it means you have more features, right? Say, for example, you start with an MVP, right? When you need to go full scale, now, when you need to add more features to your application, for example, right? That is an example of scaling, right? That's an example of scaling. That's an example of your app growing. When you have more users, that's also an example of your application growing, because the applications that could support, only a few thousand users, right? Where if you introduce the same application to like a million users, right? Such application might break, or there might be some slow time, there might be some, issues here and there, right? And also another thing is scaling from solo developers, for example, to large teams, right? Scaling from solo developers to large team is also an example of when your application is scaling, right? So these are just a few things that we need to keep in mind when we're talking about scalability and robustness of an application, right? So the first and most important thing I think that one needs to look at or pay attention to when thinking about scalability of an application is choosing the right architecture for your system, right? So an architecture of the system will make or break the system essentially, right? If you choose the wrong thing, right? If you choose the wrong architecture, you might eventually fall into the pit of having an application that will not be easily maintainable. If, for example, you just decide to just put everything in a few files, your UI, your logic, and even your controller all within a single file, you might be able to write, you might be able to make it work when the application is smaller, but when it gets bigger, then there will be a problem. So that's why I think the architecture of the system is a very important and key factor, right? When you are choosing, I mean, when you are thinking or ensuring that your application support a larger user base or scales properly. So what is a good architecture? Essentially, a good architecture is just one that allows you to still have the same amount of control, right? The same amount of control, I like to call it, within your code base when you have a smaller code base compared to when you have a larger code base, right? So it's like you already have a template or a blueprint that allows you to, that you model your system against, such that no matter how big the system becomes, right, you're still able to, bring the same thing, like the same idea from when it is smaller, you still use that same idea when it is bigger. So that's an architecture, a good architecture. It's just like you building a house, right? If you build a model of the house, you can build a model from the architecture. You can also build the main application from the architecture of the house. You see, right? So choosing the right architecture for your system is a very important aspect of ensuring that your application scales properly. So some, I'll say good architectures, right? That you can make use of include MVC, model, view, and controller. In MVC, you sort of divide your application or your code base into three major sections, right? There is the models, right? That includes how you structure your data, how your data will be converted. For example, if you're fetching your data from the backend, you can simply convert it into a model at the front end, right? Then the view is usually the user interface, right? And the controller is where the logic resides, right? So you put your logic in the controller, the view shows the UI, and the model can sort of control the data, right? So with that, you're able to properly structure your application. So it's like you are separating a different room for your parlor, another room for your bedroom, another room for the toilet, right? That will ensure that you do not have a clustered house at the end of the day, right? So using MVC is a very good architecture, I'll say. Right, MVVM is a bit close to what I've just explained, right? But it's just a little bit different. You have the model, view model, I think is yes, view model, and yes, model view and then view model, right? So within the model, you still have the same thing as you have in your MVC, right? The view is still the view, and then the view model serves like a controller, and it stands between the view and the model, right? Sort of, so it controls both sides. It fetches data from the backend, right? Uses the model to say, oh, this is how the data should look like, and it sends that model to the user, to the user interface, right, which is the view, right? So it looks, I think the names are usually, interchangeable, sort of, right? But the idea here is that you ensure that you have your views separated from your controller, and you have your controller separated from your models, right? And with that, you ensure that you have a very stable and proper architecture. So this code base by the side shows an example of a counter view and a counter view model, right? So the counter view shows the user interface, right? It just shows the count, right? And a button to increment the count. So instead of the logic to reside inside the counter view, the logic reside inside the counter view model, right? Where you can do or perform some operations on the count. You can increase it, you can decrease it. So in this example, I'm just showing how you can increase the count, right? By clicking the button. Right, so the button you can see is interfacing with the control counter view model, right? And with this, you can have a proper separation of concern. And when you need to make any change to the logic, you don't have to come or change or make any effect on the user interface, right? When you need to change anything in the user interface, the logic is still intact. That's a very good way to ensure that when your application scales, right, everything is still in place and nothing is getting mixed up or getting messed up. Right. So 1 second. Yes, there is also clean architecture. So what clean architecture really talks about is ensuring that you are modularizing your system or your application, right? Such that instead of it to just put everything, all together, you ensure that you have a model, a separate model for each item or for each feature, so that when you are building, right, you're not just building everything all together. In fact, you can have a separate module, a separate folder for each module, and within that, you can have a separate model folder, a separate view folder, a separate controller folder. I think there's an example in, yes, so I'll go back, but this is a sample model architecture. You can see by the side, we have multiple modules. We have the account module, the address module, the authentication module, and in fact, within the authentication module, there is a separate folder for forgot password module. there is one for sign in, there is one for sign up, right? So this is ensuring that you're not jam packing, you're not, just putting things all together. And with this, when you need to make change to only the sign in, you don't have to come to the sign up, you don't have to come to authentication. I mean, you don't have to come to forgot password. Everything is well structured and easily navigatable. You can easily move from one folder to another, right? So this is an example of what a clean architecture dictates, right? And then there is block, right? Usually, well, it still falls on the architecture, so to some in some way, right? So it stands. It's an acronym for business logic, right? And it's a package generally used in Flutter to ensure that you have your logic in a separate place. Although the package itself does something way more than that, but the underlying architecture, the underlying thing about the block is that you have proper separation of concern, right? You have a block to represent your logic, and you have your UI separate, right? So we can still put it on the architecture, even though directly itself it's not an architecture of itself. But yeah, we just go on. So we have architecting for growth. These are some key items that we need to pay some attention to, like adopt modular architecture, feature-based folders or packages, as I showed earlier, where a folder represents each of the features or modules within the system. Ensure to implement a clean architecture or data-driven or domain-driven design, right? So depending on what you're building, right, you should ensure that the architecture that you're using follows suit, right, so that it fits that particular use case. And then keep business logic separate from UI. This is the golden rule, right? When you are building an application, if you intend or if you want it to be scalable in the future, if you want it to not break due to some minor changes, and you need to ensure that the business logic is separate from the user interface, and you can make changes to each one of them independently. I think you have seen this before, a sample modular architecture, highlighting how we have different folders for each item. And one other thing here is scale state, not spaghetti. Right? I don't know how I came about this heading, but the whole idea is that ensure that you're scaling the state, right? You're not just mixing things up, right? So we need to ensure that we use predictable and testable state managers like a block or qubit or river pod, right? So as opposed to just putting everything together and just setting state here and there, right? When we only need to change a particular module or a separate or a section of the user interface, right? We need to ensure that we are using predictable state management techniques like block, right, or river pod, right, or even providers and other state management techniques, right? So keep UI stateless as much as possible, as much as possible. A very key and important thing is that the user interface should be as stateless as possible, right? We only use a stateful widget when the needs arise or when you need to do. Keep business logic isolated and state single sourced, right? So that you don't come and get a particular state, the same state, right, on one page, and then you have another source for the same data on another page, right? That will cause a lot of trouble, right? That will cause a lot of trouble because someone might come another day and then they will only make changes to a particular source and they will forget the other one. But if the state is single sourced, it's within one provider, for example, you're always able to make a predictable change to that particular state, and it will affect or it will take effect all around the application. And then avoid states, avoid set state soup in large applications. For example, when the application is quite big, or let's say you have a what's it called? A state, I mean, a page, right, with multiple tabs, right? And then you are setting states in the main page, right? That's a lot of problem because you'll be rebuilding every single tab within that particular widget, right? So it's always better and preferable to ensure that you're not setting states in a very large, or in a big, since widgets is like in a tree, sort of, right? It's in a tree. If you set state at the top sections, you are literally making changes to everything that comes under it, right? So we should always ensure that we are not setting states where we don't need to set states. Always make changes where and in the particular section that you need those changes to be effective. I think we'll see some examples in code as we go on. And this is sample qubit implementation, right? So to initiate or create a new qubit, you can just create a qubit class, right? And it needs to extend the qubit class, right? And you specify the type of the data that will be returned, and you can make changes to the state within the body of the qubit class, right? For example, in this case, we are simply incrementing and yes, we are simply increasing and decreasing the values of the state, right? Which is an integer in this case. So it could be more complex than this, but this is a simple form of a sample qubit, right? So these are some performance optimization techniques and stuff that you can do to ensure that the performance of your application is still maintained as the application grows, right? We should always try to avoid unnecessary widget builds, right? Make use of const to ensure that if you make a change or you change something, whatever does not need to change or whatever does not need to be rebuilt does not get rebuilt. So make use of const as much as possible. I use selector to ensure that you're not, listening to every single event change within a provider, for example, right? Or a qubit, for example. So you only um, highlight or identify the state that you want to listen to in case you are managing multiple states within a particular qubit or within a provider or anything like that. And make use of value listenable builder. So a value listenable builder allows us to listen to a single value, and when it changes, there will be a rebuild, right? So as opposed to having a block where you can have multiple states within it, right? A value listenable, right, is a single value that you can listen to within your application, and you have a single source of truth, and you can, you know, listen in multiple places, and whenever you need to make a change to the particular value, you just change the value and it will be affected all across the application. Also, should try to use isolate for CPU heavy tasks. So an isolate in that, right? Yeah, in Flutter or in that, right, is like having a separate thread in other programming languages. Although it's not a thread of its own, but an isolate ensure that you're not using resources that is being used for the main thread or for the main. It's like you're separating some activity or some processes away from the main thread, right? So that the user interface does not hang or does not get, and your application does not crash, right? So when you intend to do some resource heavy activities or CPU heavy task, you can make use of isolate. We'll see how to use that within our Flutter application as we go on. And also to ensure that we are not always, poaching or always downloading unnecessarily from the internet. We can use or catch our data locally using Hive or SQLite or shared preference, right? To just save some data offline, and instead of having to make calls to the API or internet every time, you can simply get the data locally, and that's faster. And if the only downside is we have limited amount of space, and we should use it wisely so that we don't keep catching unnecessary data on users' devices. And then optimize images. Right. Let's see, using packages like Catch Network Image can ensure that we are not always downloading images every time the application changes or move from one place to another and stuff like that. If an image is downloaded once, we can simply catch it and we can, reuse it when we need the image again subsequently. These are some helpful concepts that will help us as application grows. Use of singletons, right? So a singleton is just like having a single instance of a class within our entire application, essentially, so that we don't have to create multiple instances because each instance requires some resources, right? And if you can make do with only one single instance, why not? Right. So singleton design pattern tells us that we should make use of a single instance of a class if that is sufficient for our use case. So we'll see an example in the coming slide, right? So also dependency injection. So we can make use of packages like Getit or Riverport to inject some singletons at the beginning of our application launch so that you can make use of that throughout the course of the user session. We don't have to create multiple instances of the same classes multiple times, as long as we can make use of a single instance, right? And ensure that error handling is seen as a first class citizen, right? So as opposed to thinking or managing errors after after you have done or after you have completed your logic, ensure that error handling is always at the forefront of whatever you're doing, and you're always handling errors properly and gracefully, right? And we can make use of interceptors, for example, for managing network error. Yeah, for managing network errors, for example. So you have a single interceptor that sort of intercepts your network API or your API calls, and there's an error, you can handle all the errors in a single place, right? In fact, you can even maybe on request, for example, you can add some header if you have a general header that you want to add to all your API calls, and this makes everything simpler, makes it more less error prone, right? Since you have a single source of truth. So you can see most of the concepts are pointing to ensuring that resources are not overused and ensuring that there is always a single source of truth. Right? Those two major concepts are things that we need to pay very good attention to. And then proper documentation. This is always uh, underemphasized, right? Or this cannot be overemphasized. I'll say it that way, right? Having a proper documentation of what you have done will help whoever is coming on board, or when you want to improve, when you want to change anything, having a proper documentation will always be a plus. You'll always be able to, see what has been done and then build on that. Okay. So as I said earlier, we're going to see some sample singleton implementation. Right. So I said a singleton is just a design pattern that tells us to have a single instance of a class and use that across the application. So as opposed to, the example that I have here is making use of shared preference. And as opposed to us waiting or awaiting the instance of the shared preference class every single time we need to create, or that we need to access the shared preference, right? We can simply have a manager, right, where we have an instance of that manager, and that instance will contain an instance of a shared preference, right? I don't want to complicate it. So it's like you're having a single instance of shared preference every single time. So here we can see in the get instance method, right, in the get instance static method, we check if there is already an instance of shared preference. If there is none, then we create the double question mark equal to is checking for null first to check if the instance is null. If it is null, only then we call the await share preference dot get instance. If it is not null, we simply return the value there. We don't call the nesting, and we return the instance. With this, we ensure that we always have a single instance of the shared preference class within our application, right? And this will save us a lot of resources, right? Because you always have to await the shared preference of get instance call. And if you have to do that every single time you need to use shared preference, then oh, await some serious reviews. Right? So it's always better to have a single instance of some classes if it is sufficient to have a single instance, right? So there is also avoid unnecessary use of stateful widgets and reviews. I think we talked about this earlier. So this is an example code that's just telling us that, say for example, I think I made this example earlier. We have a default tab controller with two tabs, right? We could make this home page a stateful widget, right? Nothing is going to happen, but then it is very unnecessary. It is very unnecessary because the stuffs that will be changing are within the tabs. Usually, they are within the tabs. So the home page can simply be a stateless widget. You can see in line one, set class home page extend stateless widget. So this will ensure that we are not unnecessarily using a stateful widget, and we do not mistakenly call any set state within this home page, because calling set state within this home page will literally rebuild the entire body, and that is going to rebuild the tab view, which is going to rebuild the static tab and also the counter tab. That is very unnecessary, right? So ensuring that we do not unnecessarily make rebuild calls or call set state within our widget is very essential to having a scalable and maintainable application, right? Yes, and a robust application, just to ensure that it is very efficient, and when multiple users use it, it doesn't break, and when there is heavier use of the application still stands. And then this is a sample isolate implementation for every task, right? So we can see the run isolate method. Within it, we have this is sort of there are two ways to create an isolate, but this is the extensive way, right? Where you can have an option to send some data within the isolate to the main thread, because you cannot show data, or even you cannot perform some activities like accessing shared preference, or like sending some things to the user interface. You cannot do that directly within the isolate. So we always have a receiver port where we listen to data from the isolate, and we can use that data to update. Let's say, for example, if you are downloading, right? So in this case, in this example, we are doing some heavy calculation. We are summing the numbers from 1 to, oh, this is a very big number, I think 1 billion, right? So this is a quite heavy computation. And when there is a new data, right, when the computation is completed or when something happens, we are listening within the receiver port. I mean, using the receiver port, you can see on line 67, we say receiver port dot listen, and we're listening for the data, right? When the data is returned, right, we want to use it to show some things on the user interface, right? So the send port will be used within the isolate itself to send data to the receiver port, right? So within the receiver port operates in the main thread. So you can do a lot of things. You can literally do everything within the application. You can call set state within the receiver port. You can, you know, access some local data. You can call it, make API calls and stuff like that. So the receiver port listing for isolate operations, and the send port is used to send data to the receiver port, right? I think if there's any question regarding this, I can try to break it down further in the QA section, but I think I've made some justice to it. So these are some things or some general advice on how to ensure that when the application gets bigger, we do not start encountering multiple problems. So it says more hands, more code, less chaos. To ensure this is happening, we will need to modularize early or regret later. We need to ensure that we have our folders properly, I mean, our features properly modularized, have separate folders for different things, so that one person can be working on authentication, another person can be working on, say, cards, another person can be working on payments and stuff like that. And with this, we don't step on each other's toes, and everyone can work independently. And at the end of the day, we can continuously uh, integrate our code base together, right? And then define a clear architecture and stick to it, right? Pick a clear architecture and stick to it. Whatever architecture you are going with, ensure that it is communicated to everyone and everyone is following the same architecture within within the application, such that if another person is to come on board, right, they just need to maybe read some architectural documentation of the system, and they'll be able to make updates, they'll be able to make changes easily to the application. And then establish ownership. Ensure that each module, for example, is owned by an individual, right? So such that if I and Joseph and maybe and I are working on the same project, I know that, oh, I own the authentication module, Anna owns the payments module, right? And whatever happens to that particular module, we get to know that, oh, this is who should know more about it, right? So that helps us to ensure that, oh, every single part is properly owned, and everyone is taking responsibility for the part they have worked on. Right? It helps to a very great extent. And then set up automated quality gates. Right? So automated quality gates include stuff like lint rules and static analysis. Right? With lint rules, we can specify that, oh, this is the naming convention that we want to use, or it could not be just lint. You can specify that, oh, the user interface file should not be more than 150 lines. The logic file should not be more than 300 lines, right? So all these rules helps us to, get keep the application code base and ensure that nothing is, spilling away, or no one is, performing any wonder that will not understand in the future, right? And then empower, don't micromanage. Whenever anyone is working, or when you have multiple people working on the same code base, instead of checking what they are doing one by one and just making changes by yourself and stuff like that, or micromanaging the developers, ensure to empower them and let them know that, oh, they own this and they should take charge of it, only guide and try to help them move along and navigate the code base, right? With this, you ensure that there is less chaos as there is more hands, even though the application is scaling and more developers are coming on board. And then I think the big gun, at the end of the day, whatever happens, whatever the sorry, whatever the no matter how strong an application is, no matter how well built the application is at the end of the day as fast as the backend, right? So when the Flutter application is scaling, the backend also has to scale because when you have more people using the application, for example, even though you are properly managing everything at the front end, if the back end does not scale properly, then there will be issue. The application will eventually will be slow because you'll be waiting. You have a long wait time for the APIs to respond. The servers might just, you know, stop responding, and different issues might occur. So we need to keep it at the back of our mind, right? Even though you might be a front end engineer, you need to put it at the back of your mind that the back end must also scale, right? And it's also always available, right? So one of the things that we can, or things that we can also use to ensure that we are helping at the front end include stuff like making use of paginations as opposed to requesting for large number or large data sets. You can try to paginate and fetch in batches, and this will put lesser load on the back end as well, and the application response time will also be faster. The user will always have something to play with, and they don't have to wait forever for data to show. And then there's also catching, right? Ensuring that whatever data is required multiple times, as opposed to always just calling the backend for the data every single time, you can try to catch the data and make use of the cached version when the backend does not respond early, or not even call the backend at all if the data is supposed to be the same thing, right? And then make use of GraphQL, right? So with GraphQL, you're able to specify exactly the data points that you need, right? One by one. And with that, you don't request for unnecessary data because a lot of time, there are times where all you need is just maybe like the title or the URL of an image. Whereas the backend is just fetching the entire information about the image and throwing it at you. Right? But with GraphQL, you can specify exactly what you need, and that's the only thing that will be sent to you. And that will ensure that there is no unnecessary overload or necessary data being thrown at you from the backend, and makes the application faster at the end of the day on the long run. And one other thing that you can do as a Flutter developer is integrate with cloud services that scale, right? We always want to jump or make the conclusion to move to our own custom backend. But usually, I believe a lot of applications, although I've worked on some large scale application that needs a dedicated backend, but a lot of times we see some small applications, right, that can make use of cloud services that easily scales. You don't have to do anything like Firebase, right? You can make use of Firebase Firestore for your storage, Firebase storage for storing your files, uh, you know, Firebase remote config for storing some remote configuration files, file analytics, Crashlytics. A lot of other services are integrated together to ensure that your application can work easily, and you can be rest assured that your backend is always stable. So when you can, always try to opt in or switch to cloud services that scales, right? Like Firebase. And this is a very integral and very important part of scaling your application. And then automate consistency. Automation is how scalable teams move quickly and safely, right? At the end of the day, if you're always doing something one at a time, you're always following steps to do something, it's not properly automated, you're prone to making errors, you're prone to making mistakes. Automation helps us to reduce the errors that we make in a process flow, ensures that whatever we want to do is always done correctly in the laid down manner and approach that we have specified earlier. And making use of tools like CodeMagic, GitHub Actions, etc. for CI/CD is a very important way to go, right? A very important way to go to ensure that we automate some parts of the workings of the system. Like if you want to deploy, some testing can be automated, deployment can be automated, and some checks can be automated. And with AI, you can even automate reviews, right? Such that when a pull request is made by some developers, you can use artificial intelligence to review whatever you have done and to give you proper and in-depth review documents, and you can follow them. In fact, you can even make changes. I believe this is not the class for that, but essentially, we should try to automate as much as possible. And then there's quality and testing and quality assurance, right? Write test a particular function, right, and ensure that it is working correctly. A widget test the widget, and integration test a flow from end to end, for example, right? So ensure to make good use of all these testing types. I mean, of all these testings, of all these types of testing, right? To ensure that the application is properly handled, and when it scales, right, you can easily still test, or you can easily run tests and ensure that you have not broken anything in the previous code base or in the previous reviews of the application. And always ensure to test critical flows early, right? When you make some changes, ensure to still test the authentication flow, ensure that the payment is still working correctly and the application is navigating properly. Ensure to always have some general testing, right, before you push or before you make any update to your application. And it's a sample unit test. This test to ensure that the counter at the increment and the decrement methods are working correctly. These are the methods that was inside the counter view model that we saw earlier, and it's just quite straightforward. We have a test group. One is checking that the initial value is 0 with the expect method on line 8. It checks and say that, oh, is the counter dot value method, I mean value, is it 0? Right? If it is if the value that is expected is there, you get a successful test. If it is not, you get a failed test. You can easily check that, oh, this what has happened, what has changed. Also, the increment value by one test, it's get access to the counter class or instance of the counter class, and it calls counter or increment, and then it checks the value. Is the value now one? Right. So that's essentially how test works. You simulate some updates or some changes to uh, call some methods, right? And then you check, is the value that is there, is it what I expect to be there, right? If it is not, then you know that oh, something is wrong. The increment method must have been touched or is now working wrongly. The same thing happens for the decrement method, right? So this is a simple unit test sample. And widget test, test the widget, right? So you can pump the widget, right? And then after pumping the widget, you can expect to find some values in some widgets, right? So if on line 10 we say expect find text count with 0, right? So this is finding this text count colon 0. So if this is not found, then something is wrong, right? So if this is found, then we expect we return a successful response. And also, we are simulating the tap of the key of a widget, right? And that widget has a key with name increment, right? So we find the widget by find.by key, right? Once it is found, we tap the tester.tap taps the widget, right, which is the button, and then we pump tester.pump with it, we rebuild the widget. And then once the widget has been rebuilt, we expect that our count, instead of having count colon 0, it should now be count colon 1, right? If this is correct, that means our increment function is working correctly and our widget is properly updated. So this is a sample of a widget test, and it's quite straightforward, but your use case will define how your test will look, right? Another thing we need to pay attention to is using analytics, right? Telemetry and observability, right? So analytics gives us some insight into how the application is being used so that you know what to improve, where users are having pain points, for example, where they are dropping off in a particular flow, right? So the analytics will give you that particular insight, right? And it will give you better observability into your application. And with that, you can see how the users are using the application, where they are staying more, what they are doing with the application, and this will help you to scale better, right? So integrate analytics like Firebase or Mixpanel, add crash reporting using Firebase, Crashlytics, etc. And then use open telemetry for distributed tracing using complex backend. So with open telemetry, you can have a properly structured telemetry data, right? That includes stuff like metrics, traces, logs, right, spans, stuff like that. And with that, you can have a very, good view of what the application is doing, how the application is running, where with metrics you can see, oh, the API is taking this long and stuff like that. It will give a very good insight into the application. You know what to improve and where to improve and what and where an issue is happening. And then Finally, remember, it's one thing to learn. It takes persistence to become truly proficient. I tell this to help people with this. It is a thing to learn, right? It takes persistence. No matter how much you've learned, it takes you being persistent, consistently giving and trying and improving, right, to become truly proficient and keep fluctuating, guys. Thank you so much. I'm Tajudeen Nurudeen, and I'm a mobile software engineer. And this is the end of my presentation. I think I still have a few minutes. Do I? For question and answer. And mic to you, Anna.